and welcome to 7.4. There are going to be two parts here, 7.4a and 7.4b. Make sure you get both those in. It's kind of a combined lesson. So today we're going to talk about what we call special right triangles that include 45 degrees, 45 degrees, and 90 degrees. So the first thing we need to know is that these triangles are going to have two congruent sides as well as a right angle. Now, these are three pictures of these right here. You'll notice that the sides are all congruent and the angles are all 90, 45, 45. Now, if I solve these Pythagorean theorem for each one, we can see on the left, the middle, and the right, we get a certain pattern. Do we see the pattern? Yeah. They both have square root of 2 as part of their final answer. Now look at the first number. Leg 10, 10 square root of 2. 6, 6 square root of 2. 2, 2 square root of 2. So the hypotenuse is always square root of 2 times as long as a leg. Now, this will always be true in a 45, 45, 90 right triangle. So now we're going to see our notes in general. So make sure you write these down. So we call this an isosceles right triangle. Notice this will always form this format. They will be congruent because isosceles, and hypotenuse will always be square root of 2 times as long. So for example, let's say that this side was 2. It would be 2 square root of 2. Let's say it was 5 square root of 2. All right, now go to 7.4b, special right triangles 30, 60, 90. This time, the triangle is broken into 30 and 60 and 90, which makes 180. What we're going to do is that we're going to label these triangles as 2x, 2x, and 2x. If I draw an altitude, this side stays 2x. The bottom divides in half, so we get just x. And we're going to be looking for this leg. I labeled it A. If we use Pythagorean theorem, we could say x squared plus a squared equals 2x squared. Notice these parentheses. Use them, please. I'm going to 1 in here and remind myself, but notice here, 2x squared is actually 4x squared. 2 times 2 is 4, x squared, x squared. If I move this over, using subtraction, we get 3x squared. If I take the square root, we get that this side is equal to x square root of 3. So no matter what x is, this pattern will always be true. So what this means, the long leg is square root of 3 times longer than the short leg. Let's say this was 5 square root of 3. The hypotenuse is always double or 2 times longer than the short leg. Notice the short leg is opposite 30. The long leg is opposite 60, just like in this picture here. I also include some information here as well. So we'll be investigating both these triangles. What we're going to see now is how the problems look when we're trying to solve the missing part. So now, let's see the triad section. We're on unit number 1. We'll do the rest in class. So you see how we have a 30, 60, 90 triangle? That will be similar to a triangle that has ratios of 1, 2, and square root of 3. So 7 over 1 is equal to x over 2. If I cross multiply, we get that x is 14. Oh, that's double 7. Compare that to 7 over 1 is equal to y over square root of 3. Y is equal to 7 square root of 3, which is what we'd also expect. It's the bottom times square root of 3. Ta-da! Now, let's compare that in 7.4a. So go to 7.4a, that first try it out section. Notice here we have an isosceles right triangle. So we know it has a ratio of 1, 1, square root of 2. 1 over x, square root of 2 over 8 square root of 2. Cross multiply. X square root of 2 equals 8 square root of 2. Divide by square root of 2. X equals 8. And look at that. It follows the pattern that we expected before. I'm looking forward to talking to us in class.